Here is another example. Let's just go through the example quickly. What's example one? We have, so this is before and this is after here. So before, this trolley of mass 0.5 kilograms is moving in this direction, even though it's not written. It's moving in this direction and it collides and sticks onto not ball, but a trolley of 1 kilogram. The speed of this one was 0, so this one was stationary. The question is, what is the total speed of the both of them after the collision if they stick on together? When you can see the answer clearly, but let's just work it out. The total momentum before collision, right, would be the momentum of each of the bodies before they collide. So that's momentum of this one plus momentum of this one, which is 0.3 meters per second times 0.5 kilograms. So that's 1.5 kilograms meter per second. And since this one is stationary, because V is 0, since V equal to 0 for this one, the total momentum is 1.5 kilogram meters per second. Now afterwards, it moves off with some speed and we don't know, right? So that's why we have V equals something here. But we know that from the conservation of momentum, the momentum of the entire body would be 1.5 kilogram meters per second. The objects now have a combined mass of 1.5 kilograms, and then what we have here, okay, I didn't write this. P is equal to M times V. Basically, M is the total mass, which is 1 plus 0.5. So M is 1.5 kilograms, and the speed is something we don't know. So we just put into the equation that the total momentum before, which is this, 1.5 kilograms, is equal to the momentum of the two trolleys after, which is 1.5 kilograms, which is the mass, times the unknown speed. When we solve for V, we get that V is equal to 1 meter per second. You follow that? I went through it very quickly. We have two vehicles, like one is a car, one is maybe a truck, and they're moving in opposite directions, right? They're going to collide and stick on together, right? What is the final velocity of the, well, let's say combined vehicles, and I want you to tell me the direction that they're going to move in. Like, so when you're considering what is the momentum of the car, take into consideration the direction. So let us, let's do it then. So let's say momentum of P of T for truck, right? That's M times V. If we take this direction as positive, the velocity will be positive. So then that's 2100, leaving off the units, multiplied by positive 40. That's 84,000. I'm going to write now kilograms, miles per hour. P of the car before is M times V. That's 1,000. But because the car is moving in the opposite direction, the velocity of the car is negative 40. Right? So the velocity of the car is negative 40. So then that's negative 40,000 kilograms miles per hour. So the total momentum of the system, the total initial momentum of the entire system is 84,000 minus, right? Because, okay, here what? If I do it in stages, I can say plus, I'm putting brackets, negative 40,000, right? This still works out to be 84,000 minus 40,000. So that's 44,000. miles per hour. Y'all following?
Yeah.
Yeah. Kilograms, miles per hour. I'm going to leave you from here now. So continue and find the final momentum. Final momentum, PF now, would be the total mass of the bodies because they're stuck together, right? So PF, let's start with the basic equation. Momentum is mass times velocity. So the mass would be the 2100 plus the 1000 kilograms, right? So 2100 plus 1000 is 3100, right? So that's 3100 times some mass that we're trying to find. So we don't know what the mass is, right? But from,
We don't know what the velocity is.
sorry, we don't know what the velocity is, thank you. But from the principle of the conservation of momentum, Pi is equal to F, right? So this is our Pi. So therefore, 44,000, I'm using units now, kilograms miles per hour is equal to PF, which is this equation here, 3,100 kilograms times V. You follow? So now V is 44,000 divided by 3,100. Let's include the units here. So this is kilogram miles per hour divided by kilograms. This would give you 14.2, and then to get the units, this cancels that, and so the unit is miles per hour. Take you follow? Okay. Let's try this one. This one says that, well, another truck and car, right? Both of them moving now in the same direction. But after they collide, they don't stick together, right? The car, as a matter of fact, hold on, the car was stationary because you see V here is 0 meters per second. So the car alone is stationary and the truck is moving. After the collision, the car moves off at 15 meters per second and the truck, well, the truck should slow down. The truck would change speed. Calculate the new speed of the truck. All right, go ahead. Go ahead and try this one.